Welcome to Electronic Specifier Insights, the podcast for electronics engineers. I'm your host, Paige West.
In today's episode, I speak with Roland Marx, Product Manager at Swissbit. We dive into the critical world of cybersecurity with Swissbit's Security Upgrade System, which is an advanced solution designed to enhance the security of embedded and industrial applications. With cyber threats on the rise and increasing demands for secure data storage and device protection, Swissbit's approach offers a powerful and practical way to safeguard systems.
Let's get started.
Hello everyone and welcome to Electronic Specifier Insights. Today I'm pleased to be joined by Roland Marx, who is the Product Manager at Swissbit. So thanks very much for joining us, Roland. How are you today?
Yeah, fine. Thank you for having me.
You're very welcome. Why don't you start by giving us a little bit of an introduction to yourself and your background?
How about me? So I'm product manager for embedded IoT solutions at Swissbit, and it's my job to design, but also very much explain special security products that do cool things that not even I had known before I started at Swissbit. So it's a very interesting technology stack, I would call it. And so I also studied physics in Germany and flash controller. This is the first time for years that now I get in touch with physics again. So this is really interesting to see all the electrons stored somewhere in a device. But I'm also, my background, so much interested in microcontrollers, electronics, technology in general. And I'm creating and hacking things, in my spare time also. Regarding, also before my career at Swissbit, I've been embedded developer for automotive and off-highway industry, but also different industries, and also working as a cybersecurity consultant for specially embedded devices and IoT devices. So this is my technological background, and I've learned about different challenges, especially for cybersecurity in embedded systems context, and they have tons of exceptions, constraints, compared to standard IT stuff. So, and this is very special, and you cannot just take some security solution from IT and bring it down to embedded. This does not work. So, but here I am with Swissbit now. I can do what I love, and it can be very creative, find new ways to protect devices, and maybe some of these things we can also talk about in the podcast now.
Yeah, definitely. Well, thank you very much for that introduction. And perhaps for some of our listeners who aren't familiar with the company, why don't you tell us a bit about Swissbit as well?
Yeah, Swissbit, they are lead manufacturer for industrial grade storage and security products. So it's mainly, so you might not have seen us because we are not in the consumer market normally. It's really industrial products. It's also a little bit higher in the price range, but it's made for robustness and for maybe eternal life, if you want to call it like this. So these flash things should not fail until, or maybe before the hardware, the electronics that you have fail. Our headquarters is in Switzerland. This is where our name is also coming from, but also our security features and the production is in Germany. So we have really a semiconductor fab in Berlin, which is really cool and very modern. So it's really nice to also watch it. And our mission is to combine reliable memory with built-in data protection and security. So this is also my major task. And next year we celebrate our 25th anniversary. So we also not with our product, but also as a company stand for durability and innovation.
Fantastic. You're going to have a big 25th birthday party?
I hope so, yes. but I'm not sure what is planned yet.
Fantastic. So in today's episode then, we're going to dive into the critical world of cybersecurity with Swissbit's Security Upgrade System, an advanced solution designed to enhance the security of embedded and industrial applications. With cyber threats on the rise and increasing demands for secure data storage and device protection, Swissbit's approach offers a powerful and practical way to safeguard systems. Now, this innovation has gained industry recognition, winning Electronic Specifier's Electronics Excellence Award at Embedded World 2025, which we'll talk more about later. But Roland, to start off with, why don't you give us an overview of Swissbit's Security Upgrade System and what challenges it aims to solve?
Yeah, so actually thinking about the challenges, I might maybe give a little introduction or story that you could maybe follow. So if you think your producer or your manufacturing company And you might put an IoT device somewhere that should monitor some important parameters and report them back to your backend, to your company. Yeah, so at a certain point in time, you will install this in a potentially remote location, so nobody's really nearby, nobody should do service on it, and you leave it there for many, many years normally. So many devices have lifespans for like 5 to 15 years. So this is quite normal. So long time. You maybe do updates for the Linux, so you patch vulnerabilities in the software, and you do everything that's security best practice, like having long passwords, having unique passwords, and so on, restricting the access to the device. But yeah, day by day you receive the data, but suddenly the data does not seem correctly. So maybe you see some different variations, but still, yeah, you're wondering. It does not seem to be very bad, but you're wondering what's going on with the system, whether where it measures might be broken or so. And after a while, you decide to send out a service technician to fix the issue. But the service technician then realized that the device is not even active, so it's not connected to the power grid at all. So the data is coming, but not from the device. And these kinds of things happen. And the question is like, how can they happen? What's happening here? So I did proper security, at least I thought this, but still somehow someone is sending data to my backend. So which is definitely fake because the device itself is not sending it. And so it turned out an attacker was able to take a closer look and be physically around the device and could retrieve the credentials from it. Yeah, so the data that is stored on the device can be retrieved by some means. Some are very easy, like if you take an SD card where you have maybe your holiday pictures on it, it's easy for everybody to take these pictures from the card. So there's no protection at all. And yeah, so some of this was possible. And if you think of all the data, so you don't really know when this breach happened. Yeah, so you might have recorded data for a long time, but they're all fake. And maybe you did some business decisions on this. So maybe you said, okay, maybe I can postpone the maintenance interval for maybe another year because everything looks so great. Yeah, so this is just one very easy example, I would say, of things that can happen. Yeah, and in this case, so what could be the possible attack here? So it could be like the thing with a camera where you take your holiday pictures, that somebody maybe has stored an access secret or secret configuration part or the URL of your backend server and so on, and place this on the micro SD card. But why should anybody do that? Yeah, so it's actually not a good idea, but most of these devices don't have a display. You have no keyboard. You cannot enter these things. So very often it's used that you have such a kind of pluggable device so that the installation technician can put it in his notepad, put it on the configuration file, then put it back to the device. The device can read it. Everything's fine. Everything's working. But this had, in this case, any local people were not really considered as a potential threat. Yeah, and this changes more and more as we see it now. So there could be easy attacks with limited time that you need to do this, also limited resources, and many systems were not designed to be protected here. And this is actually where our security upgrade kits comes into play. So we can very good store data and protect data securely on even SD cards. Now, this is what I mentioned before. I was not aware that this is even possible. And then I encountered Swissbit and they explained it to me, and it's really cool. And so, and the magic source here is that we have our own flash controllers that interact between the embedded device and on the other side, the bits and bytes, the electrons that store the data. And here we can say, you are only allowed to see certain part of the data. Maybe you can also say certain part of the data is read only, so you can never ever change what is written on the flash. So this is also very important for integrity protection. So if you want to be sure that your applications are still the same as they have been during the manufacturing process, for example. And so this is what the security upgrade kit is doing. So it's changing the behavior of a normal micro SD card, but also other like solderable things, and to protect data and to reach certain very common use cases for cybersecurity.
Mm-hmm. So following on from that then, how exactly does your kit enhance security for embedded and industrial applications?
Yeah, so as I said before, it's actually storing or locking critical data. So, and what this critical data might be, this is open to every customer. So it could be like your pictures, but it could also be a configuration file. It could be an AI model or parameter, and it's just locked so that only the system can see the data that should be able to see the data. That's more or less it. Yeah. So, and this can be used in different industries. It can be used for different use cases, like storing secrets to log into a backend or your VPN credentials, your Wi-Fi passwords, your local user passwords, but also the log files. So coming back to this first example, so maybe at some point in time the device has seen, hey, somebody is attacking me, and maybe it even put a log record somewhere. But if the attacker is able to delete these logs later because he has root access on an embedded device, then he can just wipe all the data and nobody will have a clue when and what happened. This is very critical. So as a company, you want to know when did it happen? When did it start? So that you can roll back to the point in time before that.
Mhm.
And in all these use cases, they can easily be done with our solution. So I would say it's a generic toolbox, and you have to learn what it can do. And this is also described on our website, in our community portal. And then you have to derive your personal security fitting, security plan fitter here, how to use the product exactly.
Mm. And how easy is it to integrate into existing systems?
So actually, it's quite easy. And this is my major task to make this easier and easier together with our application engineering team. So in general, the card works out of the box like any normal micro SD card. So if you have micro SD cards before, you can just do all the normal process steps as you did them before. You can flash them, you can put files on them, you can read them, you can write them. But at some point in time, you want to set up the configuration for the protection scheme. So say if it's read only, read write, if it's public, if it's hidden, and this is done by some tools. So this is one change. So you need to configure the card, but this can be also fully automated with our CLI tools or with the desktop application. And then the second part is like how the embedded system will communicate to the card so that it can say, hey, I'm the authentic device. Please let me in, show me the data. And so for this, we have plenty examples for different kinds of systems. So we have examples for embedded Linux systems. We even have a very good example for the Raspberry Pi that everybody knows. And also everybody knows the Raspberry Pi for its insecurity. So it's definitely not built with security in mind. So everything you store on the Raspberry Pi, having a micro SD card, for example, is completely at risk if you just have this micro SD card in hand. You can change everything. And for these things, we have even an example how you can do secure boot. So how you can say that if any attacker would take out the card, he would not be able to change a bit on this card, and he would not be able to retrieve the applications, the passwords, not even the encrypted ones or the hashed ones. This would not be possible. And these things, we have example code that you can integrate into your system. And we even have this now, or we are currently doing this for systems like ESP32, STM32, Arduino kind of board, so that that you see different kinds of ways how you can integrate this. You get the code open source and can just implement it into your systems. If it comes to time, I would say it's between hours and days. So depending on what kind of system you have, you may want to play around with it also. So then this would be more like in the more days or maybe weeks. So if you want to definitely be sure everything's behaving in all situations. But if you're not able to do this all on your own, we also have integration partners that are quite familiar with our products, that are always in contact with our application engineers, and they can definitely do whatever is possible with these kinds of devices.
Excellent. And you've given us some good examples already, but what industries and applications in particular do you think benefit the most from your kit?
Yeah, to me, so our target groups or our like whatever companies that would have the biggest profit of it would be two kinds of types. So one is maybe you've heard about Cyber Resilience Act. So this is a new regulation coming up in the next years. And there it's not allowed to sell products that have not been built with security in mind by design. And so there I see a big challenge for many smaller sizes or smaller products with a smaller run rate, that they might need to be completely redesigned, which could not be economically. And here, I think there is a big chance to use something that you can plug or solder on an existing system and protect it so that it's much more secure than before and will also comply to this regulation. So this is one thing. So everybody that is now in fear, is my system, can I protect the personal data of my customers using encryption? Maybe you cannot do this on board, but in our micro SD card, it's done, for example. So this might be one very easy fit. And then there are different, I would say like use cases where you have existing systems that are already in use, like this IoT device that I told about. So if you use them already, or if it's an existing product that you don't want to retire soon, then also you can think about upgrading the micro SD card and then upgrading your overall system security to protect your configurations. And this is especially important in all the critical infrastructure companies. So electricity, renewable energy, oil, gas, water, production systems. So here there's really a chance that even in your existing systems, you can enhance the operational security so that nobody can interfere with that. And mainly there, it's the product where it would fit in would be industrial controllers, PLCs, IX systems, network and IoT gateways, cameras with or without AI, medical devices, or even secure logging servers or small logging devices in these critical infrastructures.
Okay, you mentioned regulations. So how does Swissbit ensure long-term reliability and security compliance with these evolving cybersecurity standards?
Yeah, so long-lasting compliance, I think this is hard. At least long-lasting flash, that's our daily business. So we designed our flash to be very long-lasting and industrial grade, so from the temperature ranges, but also we configure the flash to be in a pseudo single level cell mode. So you have like 10 times longer lifespan of these kinds of flashes than a normal industrial flash. So this is the one thing. And regarding compliance, it's a little bit more tricky. So we aim that we can give our customers the best arguments, how they can later say, hey, this is the reason why we think the personal data stored or maybe computed on the module is secure and will always be. And so we provide the arguments for these single items, and then our customer has to make up his own security concept from this, and then and only he can comply with his product to this regulation. So it's not, so we cannot say plug it in and then you comply. Yeah. Many marketing people like to say that, and but I cannot do this. So I'm developer. I will never say it's so easy. We do everything that is easier and easier with examples, with example argumentation lines that you can follow, that you can maybe even copy and paste. And we do also pre-checks with companies that do pen testing, or in Germany it's called TÜV, or some other notified bodies that can do these checks and audits. This is what we do. We try to do this as far as possible, but at the end, the customer also needs to do a certain part of the job and of the task. But the important thing is all these regulations, they are not rocket science. They just want security best practice, like we know them for 10 or more years. It's secure boot. It's that you want to have confidentiality for certain assets, that so that you maybe use encryption or whatever. And these basic blocks is what we have in our product. I'm totally sure we can do long-lasting security, but long-lasting compliance, this might be at the end the customer's concept for security in his products.
Okay, that makes sense. And I'm interested to hear, with the rise of cybersecurity threats in IoT and industrial systems, how do you see security requirements evolving?
Yeah, so as I said before, so it's not completely evolving, I would say. So what you should do, this is, I think, for 20 or more years, so there are some best practices that are still not done on embedded systems because they might cost. So they might cost, they might be complicated. For example, one standard thing is that you should have unique credentials per device. So that if one password gets stolen, you cannot use it on all the other devices out there in the world. But that means every device needs to be manufactured individually. So you have like an additional step where you do this unique key or password setting. Yeah, so this takes time, and time can be translated to money. And this is at the end the reason why there's not so much security out there. This is changing. So I think not the requirements themselves change, but now the demand is changing. On the one side from the regulators, but on the other side also the companies now really see, with everything shifting and then shaking in the world, that some things cannot be certain, that seem to be certain. And so maybe also your attacker model, as we call it, seems to change. So before, maybe you trusted every employee in your company, but now you might rethink if this is true.
Mhm.
Maybe you outsourced certain stuff, and maybe for a couple of $100, somebody would do stuff just to earn some extra money. So it does not need to be the person himself that's attacking, but maybe they are just used to attack you. And these things change, and these things evolve, and hopefully also with the regulation, we see a rising level of security all over the industry.
Yeah, definitely. And I mentioned earlier that this product won our Electronics Excellence Award, Embedded World 2025. So congratulations again on that. I know the judges were very impressed with the kit. What does winning this award mean for Swissbit?
I think for Swissbit, it's cool, but maybe my personal note of this, I think and I hope I'm on the right track here. So actually, yeah, so I started end of 23, and since then I mainly try to understand what kind of technology topics and things we can do and try to explain this. So before we had most of the building blocks we had for years, but we were only discussing them with very large industrial customers, and they knew about Swissbit, they knew about our security things that we could do, but not the normal, I would say, end customer, definitely not, but also not smaller companies. And this is what I want to change with this security upgrade kit, with the marketing material that I do, with all these example codes. This is not really needed for Swissbit to do, but I think it's the right choice, because there are many small companies out there and also do not know how to do security. And yeah, so this is my mission, I would like to call it. And winning the prize was really cool, and helping me on this mission to spread the word, spread the ideas that these things are possible, and also hopefully get much more successful.
Yeah, definitely. So what's next? Are there any new innovations or expansions on the horizon?
Yes, definitely. So yeah, currently the thing where we won the prize for was the form factor of micro SD card. But also micro SD cards, get designed out from time to time. So also new designs, I think they might not have them because for different reasons. So we also have already some eMMC modules where you have the same level of protection. So there the idea would be that you don't need to change your PCB. If you want to have more security, maybe you want to change the electronics board, but this is not possible if you just resolder a Swissbit eMMC on it. So then you can just do small software updates. Everything's solderable. You don't have the physical or removable device, which has pros and cons. So this is one thing that we will see very soon, and that you can also contact me for if you want to have some samples. And also the next level. So currently we have the security level 2, which means the data protection itself, so that you can hide data and so on, as I said before. But we as Swissbit, as we have our fab, we can also integrate different other microcontrollers from the die level. So really we buy from NXP, Infineon, and so on. We buy these secure elements that are nowadays in every computer. They're called TPM. They are best practice for security and can store private keys very good. And this is what you can also get inside of a micro SD card. So not only storing, but really an active security controller that is hardened for various more attacks, and that you cannot just do in software. So this is something that is also around the block, I would say. So this will be launched definitely this year and is already available. And I think end of this year and beginning next year, there will be also highly secure SSDs. So for embedded systems that have bigger power or like performance demands, that have also demands for security, but also in potentially also some IT equipment like printers and so on, or 3D printers actually. So, and here the biggest challenge is, so if you check the status of post-quantum cryptography, so this will be a breaking change for cybersecurity at all, because all PKI systems might be broken. And so the fundamentals for having trust to your devices and having trust in certificates, this might be gone at a certain point in time. And also, so here we will have post-quantum hardened systems that have signatures that use already post-quantum crypto algorithms, but also integrate post-quantum crypto secure elements, so that we can do these calculations in a very hardened way, and that you can also just retrofit, plug and play into your whatever system that uses SSDs. So this will be coming also very soon.
Fantastic. Yeah, that's certainly a very exciting topic at the moment. And it sounds like you've got a busy year ahead of you. So good luck.
Yeah, thank you.
Is there anything else you wanted to add, Roland, before we wrap up?
I think I've told a lot of things. I would be very happy to get feedback from people that test our software to help us improve. By the time you hear the podcast, I hope that our GitHub is already public. So we already have a lot of code and examples on GitHub. And if you have any ideas, you can also raise issues there, or contact our support or our partners if you want to have some integration help or guidance. Reach out to us. Also, you can find me on LinkedIn, and I'm glad to stay in touch.
Fantastic. Well, it's been a real pleasure speaking with you, Roland. Thank you very much for your time and for your insights.
You're welcome.
Thank you for listening to this latest episode of Electronic Specifier Insights. Don't forget to subscribe to the series to keep up to date with our newest guests, and do share with fellow colleagues, friends and family who may be interested in the latest news from the electronics industry.